Let's install Kubernetes. First off, I will lay out the architecture of the cluster that we are going to build with some basics of Kubernetes. Then, the prerequisites. Setting up the tools we need to get this up and running. And then the actual installation. Finally, deploy a simple app and do some testing. A Kubernetes cluster should have at least one master node, but since I'm building an SJ cluster, I will set up 3 master nodes. But why 3? A master node consists of several essential components. Kube API server as a front end for the control plane and handles all external communications, meaning that this is what we are interacting with when using command line tool like kubectl or UI like Rancher or OpenShift. Kube scheduler, which basically schedules the pods on available work nodes. Kube control manager, which runs control processes and implements governance across the cluster. And data store, an external or embedded database. You can use Postgres, MySQL, SQLite or etcd for this. Since we are using K3s, initially it supported only SQLite for embedded DB option, but as of release 1.19.5.k3s1, K3s has added full support for embedded etcd. So we'll be using embedded etcd. Well, etcd needs quorum, meaning you need odd number of nodes greater than 1 to get a majority vote. That's the reason I'm going to set up a 3-node cluster. Best practice is not to schedule any workloads other than Kubernetes control plane processes into these master nodes. Hence, I'm going to add 2 more worker nodes to the cluster to run my own workloads. Before all this, I'm going to set up a layer 4 load balancer in front of the cluster to make control plane traffic from Kubernetes agents and kube control to the API server fault tolerant instead of communicating with a selected master node. So altogether we have 1 LB node, 3 master nodes and 2 worker nodes. I'm going to use 6 identical local VMs with 2 CPUs and 2 GB memory and CentOS 8 installed. These are my IPs and host names. Node 1 to Node 3 for masters, worker 1 and 2 for workers and LB for load balancer. Also, I have already set up local DNS with hostname as cname and in domain hostname.home.lab. Okay, let's set up our load balancer node first and configure the cluster through that node using K3 sub. First of all, I'm going to disable SE Linux and reboot the node to take effect, because otherwise I will have to configure it to allow port since these are non-standard ports. I will put a link to all the commands and config in the description. Now that's done, let's install Nginx. I'm using DNF package manager, DNF install Nginx. Kubernetes API server uses port 6443, so with this block of code, we can set up a proxy for TCP and UDP traffic on port 6443 to our master nodes. Notice the upstream K3s block balances the load among 3 master nodes and server block exposes it in the load balancer node on the same port. That's it. We have our load balancer. All we have to do now is enable the service so it would survive a reboot and start it. Done. And now I will install K3 sub. It's a handy little tool that SSH into a remote host and install K3s. You can get it from here, and the installation is really easy. For K3 sub to work, we need to set up passwordless SSH access to the nodes we are going to install K3s into. Okay, let's set it up real quick. Alright, before getting into cluster installation, let's install kubectl, the command line tool we'll be using to talk to our clusters. Just like K3s, few commands, download, and install. Cool. And now we install the first master node. If you want a specific Kubernetes version, you can use --k3s-version equals and the version number. And cluster flag is what tells it to start the server in cluster mode using embedded etcd. I have put my load balancer IP for the TLS SAN argument as an alternative name for the certificate. Now before setting up the second node, let's see how our cluster is doing. For that, we need to configure kubectl. And to configure, we need to get the cluster certificate from the node we just installed. Alright, let's remote into it and copy and paste it into .kube/config file in the home directory. And then edit it and modify the local address to our load balancer IP. This way kubectl will be talking to the load balancer. Done. And now we can run kubectl get nodes, and we can see our first master node up and running. Alright, let's spin up other two master nodes to join the cluster with the command k3 sub join. Let's check our cluster status. Seems the last node is still getting ready, and give it a second. And try now. Our three master nodes are ready, and now let's join the two workers. But before that, this is the command we used to get our last master node up, and this is what we're going to use to set up our worker node. See the difference? We no longer have the server flag and the node tagged. Let's get those two workers up and running. Done. Let's see the status now. Wait a second, and all ready. And see that our workers don't have etcd and master roles like the above 3 master nodes. Perfect. But let's do some tests to see if it's really HA. For this, I'm going to deploy a really simple Nginx container and a service to the cluster. We create the deployment YAML first. Now this is a slightly modified version of the YAML that you can find in the Rancher documentation. It has both name and app labels as my site. Container port is set to 80 because we are using Nginx base image. And this toleration section is what I have added because by default Kubernetes will wait for 5 minutes to schedule the pod into another node in case of a node failure. But keep in mind that this is only one way of doing it. You can always do this globally at a cluster level too. Alright, let's save it and create a new namespace for our app. And apply the YAML we just created. Now let's see the status. It's deployed and in ready state. To access this, I'm gonna create a service and expose it as a node port. Create the YAML first. I have set the node port to be 30,000, exposed the port 8080 inside the cluster, and target port is 80, which is same as the container port of our previous container. Let's save it and deploy. Check the status. It's ready. Let's check if it's accessible from the browser. Here I'm using the IP of our first master node, but you can use any node IP. And it will be accessible because we exposed as a node port and we have our title. Good. Now if we want to confirm, we can always log into the container and change something or add some text to the HTML. Let's do that. First get the name of the pod. And log into it. Let's see what's inside Nginx config. Root is this. Let's go there. and add one little body tag. Done. Let's refresh, and there we go. Alright, now I'm going to power off the worker node which our pod is running to see what happens. Let's see which node it's running on. It's node 2. Let's power it off. And watch the cluster status. Alright, it's offline. Now let's check what will happen to our pod. We can just spun up a new pod on worker 1. Now we have to keep in mind that this new pod will have only the original content of the image and will not have the body tag we added previously. Refresh the browser and our new pod is reachable. And now let's terminate one of our master nodes and see if our cluster fails. SSH into node 1 and power off. Let's watch the cluster status. Alright, node 1 is offline. Check our pod. If you can see, we still have the old pod which was on worker 2 in terminating state. That's because it acts like a queue job, and when the worker 2 has finally recovered, and if it still has our old pod, this will terminate it and clear the status. Let's check via the browser. This time we'll have to use another IP because this is the IP of the first node which we just powered off. Let's use node 2. Good, it's reachable. Now I'm going to watch the cluster status and power up those two nodes to see if they'll automatically join the cluster. Powering them up. Nice. Now we have our cluster restored. Let's check if our old pod is still in terminating state. Still not. Let's watch it. There you go. And that's it. In next video I'll install Rancher into our cluster, and thank you for watching.